Okay, so you watch through the videos explaining the electron configuration and the quantum numbers, etc. And I want to work a problem out and kind of show you what we're discussing here. So let's pick an element on the periodic table. I'm going to pick one. I don't remember if this one was done or not, but let's look at phosphorus. Now, if you look on your periodic table, you'll see where phosphorus is located. It's in the third period. It's the 1, 2, 3, 4, 5th element over. It's on element. It's number 15. Element number 15. Okay. Now, remember what that 15 represents. Don't forget that that is equal to the number of protons, and that is also equal to the number of electrons in a neutral atom of it. So we're going to be concerning ourselves with the neutral atom of phosphorus at this point. Now, looking through what we know, it's on the third period, and so we know that it's going to be in the 3 orbitals. So here, let's sketch out a little bit of a periodic table here. Something like that. We got helium up over here, and we got hydrogen up here, over like that, and then phosphorus comes in right about here. Well, since we know that it's in this area that I've highlighted here, this little region, we know that this is going to end in a p orbital. We know that if it's in this region, it's going to end in the s orbital, and if it's in this one, it's going to end into the d orbital. Now the f's are all down here, so we know where we're going to be headed. Now, don't forget about the first period is only in s orbitals, hydrogen and helium. It's just, it's a little bit different. That's why you don't see it outlined a lot of times on some of the illustrations, especially the one that I showed you that's on this discussion page about the quantum numbers. The little periodic table, it's purple and yellow and green, and it shows out the quantum numbers there. So we can actually use the periodic table like a map, and we can devise and tell what's going on. So we know that phosphorus is in the third, because it's way down here, it's in the third period, and we know it's going to be in the 3p's. So we know it's going to end in 3p something. We just got to figure it out. So let's go start out with our off-ball principle. We have phosphorus with 15 electrons. And we know that the first energy level is going to be the 1s. Where does that come from? Well, it's that first period here, the first period, and it's only an s orbital in that one. So we know it's a 1s, and that's going to take 2 electrons. I do half fish hooks. The illustrator there did full. It just works easier for me to do half. So you know there's an arrow up and down, there's a 1s. Now when we go from the 1s, we're going to go up to the second energy level here, second period here. And so that's going to take us up to the 2s orbital. And I draw this as a line, and they go upon each other. You've heard them talk about the off-ball principle. It's building. Think of it like a ladder, and all these electrons are going up. And so here we know that we're going to have at least the 2s in both places, and that's going to take us through this section. So I'm going to highlight I'm going to color these in as we go. Okay, so we got hydrogen, helium, lithium, beryllium at this point. And then we know that we go over here to the p orbitals. Now, p orbitals, we have 3 p orbitals. In the explanation about this, that was the x, y, and z orientations of it. X, y, and z. Whether it's an x, a y, or a z, it really doesn't matter because they're all equal in energy. But we need to also remember that we can only put 1 electron in each orbital before we add 2 electrons to any of those orbitals that are all the same energy. So here we would draw this out. We'd go an up arrow, another up arrow. Then we'd come back and we'd fill in down arrow, down arrow, down arrow, down arrow. Now, counting this out, we've gotten the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've used 10 electrons at this point, and this would be the 2p energy level there. Once we go past the 2p, let's fill that in, color that in, go over here. That's all the way to the 2p. The 2p is neon over here. That's our noble gas. We'll talk about noble gas configuration on the next one. Go past 2p, the next energy is 3s, and so we'll draw a energy orbital for that. Put 2 electrons in that orbital, fill that one in there, and then we go over to the 3p. Now 3p for phosphorus, we counted it out. It was the third one. 1, 2, 3. So here we would go 1, 2, 3. I told you before it's going to end in 3p. And here it ends in 3p with 3 electrons. So that is how the electrons fill it out, the energy levels. And so the electron configuration for phosphorus would then be written 1s2, 2s2, 2p6, 3s2, 3p3. Now we could take any one of these electrons, and I'm going to take the last electron we put in there, and then we're going to come up with the quantum numbers for that electron. And so for this particular electron, this 3p3 electron, you could say, we have quantum numbers associated with it. We have the n quantum number. In this case, it's the third energy level. So that tells us that's going to be 3, L, M sub L, and then the spin quantum number. All right, so 3, so we have their n, which in this case would be the 3, the L, in this case it could be 0, 1, or 2 for the L quantum number. In this case it's going to be the 1, because this is a p orbital, because the L quantum number corresponds to the p orbital. That's going to be the type of orbital there. And then our M sub L number is going to be either -1, 0, or 1, because it can either be from negative L to L. And so here would be -1, 0, and 1. We'll erase those back out. And so in this case it would be -1. And then the spin quantum number M sub S is equal to, and we're going to say +1/2. But whether it's +1/2 or -1/2, it doesn't matter, because up and down are all relative terms.